All right, let's jump right in. In this explainer, we're going to unlock the power of Pandas, which is really the go-to Python library for any kind of serious data calculation and manipulation.
So here's the game plan. We'll kick things off by quickly defining what Pandas actually is. Then we'll walk through the setup and some core commands. After that, we're going to do a deep dive into the super powerful groupby feature, and we'll wrap up by showing you how to turn all that data into visualizations.
Okay, first up, the Pandas toolkit. So what is this thing really, and why is it so essential for anyone working with data in Python?
Well, at its heart, it's pretty much the foundational tool for data science in Python. It gives you these incredible, high-performance data structures, and the most famous one, of course, is the DataFrame. Now, you could think of a DataFrame as like an in-memory spreadsheet, but on steroids. It's totally optimized for speed and really complex operations, which makes it absolutely essential for handling everything from basic numerical tables all the way to complex time series data.
All right, let's get our hands dirty with the setup. I mean, before you can start crunching numbers, you've got to get Pandas installed and actually load your data into one of those powerful data frame structures we just talked about.
The setup is super straightforward, especially if you're already comfortable in the Python ecosystem. It's just a quick pip install pandas, then, in your script, you import it. And pretty much everyone in the world uses the alias PD. From that point, you're literally just one line of code away from loading your data, say from a CSV file, straight into a data frame.
But here's where things get really interesting. The read CSV function has some serious flexibility built right in. It's not just for your standard clean, comma-separated files. You can tweak parameters like sep to handle different delimiters, tabs, semicolons, whatever. Or you can use header to tell it exactly which row contains your column names. This means you can adapt it to a massive variety of file formats right out of the box.
Okay, so your data's loaded. Now the real fun begins, right? And let's be honest, more often than not, the first step is always cleaning and prepping that dataset before you can even think about analysis.
Right, so your first move with any real-world dataset is to find the holes, the missing values. This little chained command here, .isna.sum, is your best friend. It's like a diagnostic tool. It just instantly gives you a count of all the missing values for every single column. It's basically an instant data quality report before you go any further.
So once you've found those missing values, you've got a choice to make. The simplest, most direct approach, just get rid of them. The drop in A command, by default, will just nuke any row that has even one missing value. But what if a whole column is mostly empty or just not useful? Well, that's where you can target it specifically by setting axis equal to 1.
But just dropping data can be a bit brutal. It's not always the best move, especially if you're working with a smaller dataset where every single row is precious. So the alternative is to fill those gaps. You can use a simple static value like 0, which you see here, or you can get a little more sophisticated and fill in the blanks with a calculated value, like the average or the median for that entire column.
And sometimes you just have columns that are, well, useless for your specific analysis. It doesn't matter if they have missing values or not. The .drop method is your tool for this. It's not just for missing data. You can use it to surgically remove any column you want, just by using its name. The key thing to remember is that axis equals 1. You have to tell Pandas you're dropping a column, not a row.
Okay, let's get to the real powerhouse of Pandas. I'm talking about its core computational engine. If you want to perform any kind of complex group-based calculation, the groupby functionality, this is where all the magic really happens. The whole idea is built on this really elegant and powerful paradigm called split, apply, combine. It's exactly what it sounds like. First, you split your data into logical chunks based on some criteria. Then, you apply a function or calculation to each of those individual chunks. And finally, you combine all the results back together into a new, tidy data structure. So phase 1 is splitting. All you do is tell Pandas which column or columns you want to group by. So imagine you have a big sales data set. You might group it by region. Now here's a key detail. Just calling groupby doesn't actually split the data. Not yet. It's what we call a lazy operation. It just sets up the plan for the grouping, waiting for you to tell it what to do next. And that brings us to the apply phase. This is where you tell Pandas what you actually want to do with all those groups it just planned out. You've got a few options. You can aggregate, which means boiling each group down to a single number, like calculating the total sales for each region. You can transform the data within each group, like standardizing all the values. Or you can even filter, which means throwing out entire groups that don't meet some condition you set. And then, the final step, combine. The best part,
Pandas handles this for you, completely automatically. It takes all the results from the apply step, one from each of your groups, and it intelligently pieces them back together into a brand new data frame or a series. And typically, those keys you used for grouping, they become the new index. It's super clean.
Now this is a really crucial point, and it's all about performance. Look, you can write your own custom Python functions to apply to your groups, but the official Pandas documentation is crystal clear on this. Whenever possible, you should use the built-in optimized functions like .sum or .mean. Why? Because they're written in much faster, lower-level code. Using them will make your operations run significantly faster than a custom Python function. So always favor the built-ins.
And now for the payoff. You've done all this hard work, cleaning the data, running complex calculations. So what's next? You have to communicate what you found. And this is another area where Pandas shines. It integrates beautifully with visualization libraries, allowing you to turn your data frames directly into insightful charts with just a single command.
So let's say you need to compare values across different categories, maybe those total sales per region we just calculated. It's one line of code, .plot bar. That's it. You get a bar chart straight from your data frame. It really is that simple.
What if you want to see the distribution of values in a single column? Maybe you want to see the distribution of product prices in your data. You just select that column and call .plot.hist, and bam, you instantly get a histogram showing you the frequency of different values. It's perfect for understanding the shape of your data.
Trying to figure out if there's a relationship between two different variables? A scatter plot is what you need, and the .plot.scatter method makes it easy. You just tell it which column to put on the x-axis and which to put on the y-axis, and you can immediately start looking for correlations or other patterns.
And finally, if you just need a quick statistical summary of your numerical columns, the box plot is an absolute lifesaver. Just call .plot.box, and for each column, you'll get a plot that shows you the median, the quartiles, and any potential outliers. It's a ton of statistical information packed into one compact, easy-to-read visualization.
So, let's wrap this up. What are the key takeaways here? First, Pandas is your all-in-one toolkit for manipulating data in Python. Second, it has incredibly efficient functions like drop now and fill now for dealing with messy, real-world data. Third, its real power for complex calculations comes from that split, apply, combine strategy using the groupby method. And finally, you can go from calculation to visualization in a single line of code. When it comes right down to it, mastering these commands is a total game changer. It means you can transform raw, messy data into clear, actionable insights way more efficiently. It just fundamentally speeds up that entire journey from data to decision.